All right, so here we are. We're going to go ahead and solve equations on a set interval using our double angles. So here I've got sine 2x is equal to sine x. There's not a whole lot I can do right there unless I start changing things around. I don't even have anything squared right now because if I don't have anything squared, I don't have a Pythagorean identity, and everything's already in terms of sine, so I can't even change it. So instead, I have to change that sine 2x using my double angle identity that says that sine 2x is equal to 2 sine x cosine x. And now I just bring down the right side. Now, don't be tempted right now to go ahead and divide both sides by sine. If I did that, sure, it seems like it's going to work out for me and I could cancel out that and get 2 cosine x is equal to 1. I'm not doing that, okay? If I do that, I'm completely eliminating a possible answer. So instead, anytime you see something that you could cancel out like that, where I have something on both sides, you need to bring it over to the left or the right, whichever side, and set it equal to 0 so that you can factor. So here I have 2 sine x cosine x minus sine x, and that's equal to 0. So now I can look at that and see what do they share. Well, both terms have a sign, so I can factor that out. And so I'm going to put that out front as our GCF, and now that's on the inside is just 2 cosine x minus 1, right? And that's equal to 0. Now, notice that's cosine x. It's not cosine squared, so that's not a double angle or anything like that. It's just 2 cosine x minus 1. That's it. Now, I have some number times another number equals 0. So that now means I just set up both of these and set them equal to 0 and solve. So once I do that, what I can do from here, I just need to know where does x equal 0, and over here I'm going to add 1 and divide by 2, and so now I've got cosine x is equal to 1/2. So my final solution, and it's got to be between 0 and 2 pi, not including 2 pi. So 0, where is sine equal to 0? Well, that happens at 0 and pi. And then where does cosine equal 1/2? And that's at pi over 3. So I've got pi over 3. And then it also happens again at 5 pi over 3. Okay. Now, should I write these in ascending order so that I go from least to greatest? Yes. Do you have to? I mean, I have no idea what College Board is going to say, so I mean, it's a good habit to get into. And so that's just what I'm doing here. Okay, so now it's just ordered in least to greatest. Okay, go ahead and try this one here. I've got cosine 2x plus sine x. Just like the last one, there's nothing I can do. It's already in terms of cosines and sines. There's no Pythagorean identity. There's nothing that I can do. So instead, I'm going to use one of my identities that I have for cosine 2x. But here's the catch. Cosine 2x, I've got 3 equations that I can use. So I got to figure out which one's going to be the best one. So I've got cosine squared x minus sine squared x. Got 2 cosine squared x minus 1, and I've got 1 minus 2 sine squared x. Those are my 3 equations, okay? Now, all I'm doing is just adding that sine x at the end that I have here for this part right here. So if I look and I'm trying to solve one of these, because that's what I'm doing, is I'm solving for x, so I've got to be able to get x by itself. If I tried to do it on this first one right here, if I tried to do that, I mean, I could, but the only way I could do that is if I replace that cosine squared with a Pythagorean identity to get everything in terms of sine. Same thing down here. I'd have to change that cosine squared using a Pythagorean identity. Whereas right here with this one, it's all in terms of sine. So that's the one that I'm going to want to use. So when you're doing one of the ones with cosine 2x, that's how you're solving those problems and trying to figure out which one to use. You're figuring out which one would be the most helpful way for you to go ahead and solve what you're trying to do. So let's go ahead and pull this one right on up here. Okay, so for this problem now, in order to solve this, I've got to set it equal to 0. And then now I'm left with negative 2 sine squared x plus sine x plus 1 is equal to 0. When I'm factoring, I want my a to be positive, and right now my a is negative. So what I can do instead is I can divide all sides and all terms by a negative 1, or I can just go ahead and just add everything or subtract everything over to the other side. So what I'm going to go ahead and do is just bring everything to the other side. And now that's what I've got. So basically, you just change the signs on all of them. And the only reason I can do that is because this is a 0. If it was anything else, then it would change more things. All right. So now I've just got to factor this 2 sine squared minus sine minus 1. And so several ways that you can do that, but I'm going to go ahead and just do it by grouping. And so I'm going to turn this into negative 2 sine x plus sine x minus 1 equals 0. And so this first one right here, if I figure out what their GCF is, it's going to be 2 sine x. And so then what I'm left with is just sine x minus 1. And then I'm going to do this one right here. Well, I just have sine x minus 1. The only thing they share is a positive 1. And so then I'm left with sine x minus 1 right here. So now I've factored by grouping, and so I've got my factors as 2 sine x plus 1, and then sine x minus 1. And that's now equal to 0. And so then to finish and solve, now I've just got to set each of these up equal to 0 and figure out where those would be located. So if I have sine of x is equal to, I didn't write the equal 0, equals 0. So here sine x is going to be equal to, I would subtract 1 and divide by 2, so I get negative 1/2. And then over here, I would just add 1. So I have sine x equals 1. So where do those happen? Well, that's going to happen for sine being equal to negative 1/2. That's going to happen, let me see, at 7 pi over 6. And then 11 pi over 6, right? And then I've got where is sine equal to 1. And sine is going to equal 1 at pi over 2 and pi over 2 only. So technically, yes, these should be written from least to greatest. So my least would be pi over 2. Then I've got 7 pi over 6 and then 11 pi over 6. Okay, so there's my final answer right there for my x. All right, so my next one right here would just be, I've got cosine 2x plus cosine 4x equals 0. There's no way for me to say that this is not going to be partially god-awful, but hey, you know, we're just going to do what we can with what we've got. So here, if I've got cosine 2x, I'm going to try and make this cosine 4x kind of look like that. So let me go ahead and change that cosine 4x, and so now it's cosine 2 times 2x is equal to 0. Okay, so now I can kind of start changing things around and seeing what I can get. Cosine 2x. So if I'm going to have to replace that using one of my double angle identities, I've got to figure out which one I would want to use. Just like earlier when we did the last one right here, when we did this one, we used the 1 minus 2 sine squared because that was going to help us because it was being added to just sine x, and that way I would be able to factor that. So here, if I consider I've got a cosine 2x and I've also got a cosine 2x over here, why don't I just go ahead and just replace it instead with just the one that has just cosine in there. So that would be 2 cosine squared x minus 1. So that is going to get me that, okay? And I'm going to change it and do it in different colors so we can kind of see where things come from. Now I've got to change this one. So if I have cosine 2u, that's going to be equal to 2 cosine squared u minus 1, okay? So just like before, let u equal 2x. So now I'd have cosine 2 times 2x, and that's equal to 2 cosine squared 2x minus 1. So if you notice here on the left, this cosine 2 times 2x, that's what I've got right here. So I can change it and make it now be this, okay? So now I'm going to add 2 cosine squared 2x minus 1. And then that's going to be equal to 0. Okay? So you can see how each one of those kind of changed around. And now I can kind of start working with this and seeing what I've got. Okay? Now, if you notice here, and this is what kind of makes this one terrible, is I have cosine squared 2x. So cosine squared 2x is no different than having cosine 2x times cosine 2x, okay? If I have something like that, it's just saying I have the same thing twice, right? And they're being multiplied. So essentially what I'm going to end up having to do here is I'm going to end up having to factor. I'm going to replace that cosine 2x with 2 cosine squared x minus 1 times 2 cosine squared x minus 1, okay? So that's what I'm going to end up doing right here. I just kind of want you guys to see where this is coming from. So I'm going to bring down this 2 cosine squared x minus 1, and now I'm going to kind of change what I've got right here, this 2 cosine squared 2x. Now, keep in mind, what I just wrote over here, this cosine squared 2x, is only this part, okay? It does not include that 2 right there. So I'm going to go ahead and do plus 2 times, you can use parentheses or brackets, it doesn't matter. I'm using a bracket because I'm about to put those parentheses in so I can FOIL it. So I just think it looks a little bit more clear when I do that. So that's what I've got there. And then I still have the minus 1 on the outside there, okay? Because right here, and I just want to, again, I'm just trying to make sure that we see where these values are coming from. What I've got right here that I'm just putting between those brackets, that's just the cosine squared 2x. I still have the 2, that comes right here, and I still have the minus 1, that comes right here, okay? So now I've got to distribute that whole thing and FOIL that out, okay? So like I said, this one's pretty awful. So let's go ahead and bring some things down. So I'm going to go ahead, just bring 2 cosine squared x minus 1 down. I have that plus 2 right there. And I'm just going to go ahead and FOIL. So if I do 2 cosine squared times 2 cosine squared, that gets me 4 cosine to the 4th x. And then I'm going to do 2 cosine squared times negative 1. So that gets me negative 2 cosine squared x. I'm going to do negative 1 times 2 cosine squared. So then that's going to get me negative 2 cosine squared x. And then I'm going to have negative 1 times negative 1. So that's positive 1. And I still have that minus 1 on the end. Don't forget that little guy. Okay. All right, we're getting somewhere. All right, so now what we're going to have to do is we now need to go ahead and kind of combine like terms where I can. I've got 2 cosine squared x minus 1 plus 2. And so inside here, this right here is going to combine together. So I have 4 cosine to the 4th x minus 4 cosine squared x plus 1. I've got that minus 1 at the end. Okay. So I'm going to have to take that information and I'm going to have to keep on going. So I'm going to just kind of copy and paste this right on over to the other side over here so I can keep on going because I've run out of space. All right, so what I'm going to do here now is I'm going to go ahead and I'm going to distribute the 2. Can you do multiple things in one step? Of course you can. I'm just trying to not skip too many steps at once. I'm skipping a couple, but I'm not doing too many. So now I have 2 times 4, so that would be 8 cosine to the 4th x. And then 2 times negative 4, so minus 8 cosine squared x. And then 2 times 1, so that's going to get me plus 2. And then I have the minus 1. Okay, so now I can really combine. So now I've got 8 cosine to the 4th x. And then I've got 2 cosine squared minus 8 cosine squared, so that gets me minus 6 cosine squared x. And then I have a negative 1 minus 1. Hold on. Oh, I also have plus 2. I was like, there's something missing here. Negative 1 plus 2 minus 1, so that's just 0. And so now I'm going to set that equal to 0, because again, that's how we started this whole thing. It was all equal to 0. All right, so now this looks a lot better. Now I can see that I've got a GCF from both of these. That GCF is going to be 2 cosine squared x. And that's going to leave me with 4 cosine squared x minus 3 cosine. Oh, nope, not even, minus 3. Okay. All right. So now that's what I've got, and this is equal to 0. So now I'm just going to set both of those terms up equal to 0. So that means I'm going to have 2 cosine squared x is equal to 0, and 4 cosine squared x minus 3 is equal to 0. And so in order to solve for cosine squared over here, I'd divide both sides by 2, and so I'd get cosine squared x is equal to 0. And then I'm going to square root both sides. And so now I get cosine x is equal to, the square root of 0 is 0. Over here on this one, I'm going to add 3 and divide by 4. So that'll get me cosine squared x is equal to 3 over 4. And then I'm going to square root both sides. And so I get cosine x is equal to plus or minus the square root of 3 over 2. Remember, if I square root 3/4 is the square root of 3 divided by the square root of 4. So that's how I get the 2 right there. Okay. And now all I just need to do is just go ahead and say, where the heck does that even happen? So now I have x is equal to, well, where does cosine equal 0? That's at pi over 2 and 3 pi over 2. Okay. And where does cosine equal positive root 3 over 2 or negative root 3 over 2? And that happens at all of my pi over 6s. So I've got pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay. If I was to go ahead and write those in ascending order, then that would go pi over 6, pi over 2, 5 pi over 6, 7 pi over 6, 3 pi over 2, and 11 pi over 6. And that's all 6 of my answers. All right, so after doing that, let's go ahead and do our last problem right here, okay? So it says, in the xy plane, the terminal ray of an angle in standard position intersects the unit circle at the point with coordinates A, B. The terminal ray of a second angle in standard position intersects the circle at the coordinate point C, D. If the measure of the second angle is twice the measure of the first angle, what are the coordinates C and D in terms of A and B? So this is a College Board question, no question about it. So let's say right here, for example, if I did, well, here, let's do this. Okay, so I've got this angle right here, and let's just go ahead, let's call this my first angle, and we'll call this angle theta, okay? And then I'm gonna go ahead and do my second angle. And so if I did that, my second angle, it needs to be twice that, so it'd be about right here, okay? And so this whole angle from here to here, let's call it beta, okay? So I've got theta and beta, okay? And theta, again, I'll just reiterate that that comes from if it's in standard position, so they're coming from the same place. So this one is twice the distance as this one. And so this one right here, it says that it intersects the circle at coordinate points A, B. And this one intersects the circle at coordinate points C, D. Okay? So what we're trying to figure out is what are the coordinates for this C and D in terms of A and B. So let's kind of just do one at a time. So if what I'm trying to figure out here is, you know, which of these equations, kind of look at your multiple choice answers and see what could potentially be helpful. For me, doing this problem, I thought it was most helpful to kind of recognize that, for example, if this is on my unit circle, so I would do like I would normally do, and that means that my x value is equal to cosine beta, and my y value would be equal to sine beta, right? Well, and the exact same thing is going to happen over here with this angle as well. So my y here is going to be equal to the sine of theta, and my x here is going to be equal to cosine of theta, okay? So what we have here, when I'm doing each of these problems and trying to figure out what I've got, if I'm trying to figure out C, it's saying that it's the twice the measure of the first angle. So that's a double angle right there, okay? So it's saying I'm taking that first angle and I'm multiplying it by 2. Well, in order to figure out cosine beta in terms of theta, that means that I'm having to use a double angle formula. So if I say that C is equal to the cosine of beta, which we can agree, right? It's also equal to the cosine of 2 times theta, okay? That's my double angle, okay? So now I've got to kind of write this in terms, and as it says, in terms of A and B, okay? So that and B is really key. So the only way to get this in terms of A and B is to go ahead and use my equation for cosine 2 theta that has both cosine and sine. So now I'm going to say C is equal to cosine squared theta minus sine squared theta, okay? All right, well, cosine squared theta is equal to, let me do it over here in a different color. Cosine squared theta is going to be equal to this one squared, just like B is going to get me this one squared. So C is equal to A squared minus B squared. Because again, A is my X, B is my Y, cosine squared is my X, And so that's why that A being squared is equal right here. And the B squared right here is my Y value, and so is my sine squared, and we're using theta right here. So that's why the B goes right here. So I can already answer the question as D because that's the only one that has A squared minus B squared. But let's go ahead and let's also do the other side here. So it wants me to do both C and D. So let me show you how D is equal to 2AB, okay? So let's do this. So if I say I have D, we already said D is equal to the sine of beta, right? We already said that. Now I'm going to go ahead and say that it's equal to, because it's twice the angle, so it's equal to sine of 2 theta, okay? I'm taking that original angle and multiplying it by 2 to get my beta. These are equivalent statements right here. Okay, so now I can go ahead and use my double angle formula that says 2 sine theta cosine theta. And then because we already discussed it earlier, we had our x and our y. Well, our x is equal to cosine theta and our y is equal to sine theta. So what I've got right here for this one, my x is A in my coordinates and my y is B. So that's where I'm going. So I get 2AB. I mean, the A goes with the cosine, the B goes with the sine. It doesn't matter the order, I just wrote it alphabetically. Okay, we've got 2AB, and sure enough, that's what we've got right here. Okay, this one's a little bit tricky. You really got to understand the question and that it's saying that that second angle is twice the measure of the first one. So when I hear that twice, I'm thinking, okay, that's definitely a double angle. We also have to understand, in order to answer this question, that because it's on my unit circle, my cosine value of whatever the angle I have is equal to the x value for that angle at the coordinate point where it intersects the unit circle. Same thing for the y value. I must know that if it's on my unit circle, it's going to give me a radius of 1, and therefore my sine of whatever the angle is going to equal the y coordinate. The y coordinate and the sine of the angle are the same, just like the x coordinate and the cosine of the angle are the same when it's on the unit circle. And it does tell me that information all in the question. It's just a matter of reading these questions that are very wordy and understanding what they're asking. It takes a lot of practice, and it takes a lot of paying attention to the small details of the question. So hopefully this makes more sense to you. Let me know if you have any questions.